Okay, Assalamualaikum warahmatullahi wabarakatuh. And today I would like to talk about introduction about BASF. Okay, first of all, BASF is a subsidiary of BASF SE. It is the world's largest chemical producer. And next, it is BASF established in Malaysia in 1989 with a manufacturing plant in Pasir Gudang, Johor. Then it's produced water-based polymer dispersions such as acrylic, styrene acrylic, and styrene butadiene latex. Butadiene latex, sorry. Then the products are widely used in coatings, paints, adhesive, paper coatings, and construction chemicals. Lastly, it focuses on product quality, process safety, and sustainability of chemical manufacturing.
For the objective, firstly, we have to identify an analysis of the chemical and physical raw material that used in this manufacturing process. The second, we have to categorizations of the industrial equipment and instrumentation, including the specific mechanical and chemical functions. For the third, we have to mapping and documentation of the sequence stages involved in the production process. Number four, we have to analyze the final product specifications, quality standard, commercial or industrial application. For the second last, we have to evaluate of the implementation, compliance and effectiveness of occupational safety and health practice. For the lastly, we have to identify of the operational challenges and assessment of the existing engineering solution and development of the additional recommendation of for the process improvement. So this for our polymer dispersion plant PNID. For firstly, we will go to the premix vessel, which is in this premix vessel, the raw material will mix with other additive. For next, the solution will go to the polyreactor, which is to polymerization or a cure of the reactions. Next, about the blow down vessel, go to the stripping tower, receive that will go to the receiver. After that, you have to go to the conditioner vessel, and the second last, we have to go to Sweco filter for the filtration, and the lastly, the final product will store in the storage tank in a few with detention time.
Okay, so here we jump to the equipment that used in BASF polymer dispersion part. Okay, the first from our PNID drawings, the first of our equipment is premix vessel. The premix vessel is used to prepare and mix all raw materials before polymerization process begins. Raw materials such as water, monomers, surfactants, buffers, and additives are combined to form a homogeneous mixture. Its proper mixing ensures that all the components are evenly distributed and stable before entering the reactor. The vessel also helps stabilize the monomer emulsion and reduce the risk of coagulation during processing. And in addition, it contributes to controlling the particle size and the quality of the final polymer dispersion product. So as you can see at the right of the slide, we can see as an example of premix vessel. Okay, so the second equipment that is used from the PNID diagram is a polyreactor, or short for polymerization reactor. The polyreactor is the main processing unit where the polymerization reaction takes place. The premix from the premix vessel is transferred into the reactor under controlled operating conditions. Temperature and agitation are carefully maintained to ensure efficient mixing and heat transfer throughout the reaction. And inside the reactor, the monomers are converted into polymer particles that remain dispersed in water. The reactor plays an important role on determining product properties such as particle size, viscosity, solids content, and overall stability of the polymer dispersion.
Hello everyone, I am Nur Alia and I would like to explain the blowdown vessel. The blowdown vessel is positioned immediately after the polymerization reactor. Its primary role is to receive the polymer dispersions once the polymerization reaction has been completed. At this stage, the product is still under high pressure and elevated temperature due to the exothermic reaction. The blowdown vessel performs several important functions. First, it gradually reduces the pressure and temperature of the polymer dispersion before it is transferred to the next processing stage. This controlled pressure reduction prevents sudden flashing of volatile monomers, which could create hazardous vapor expansion. Secondly, it acts as an intermediate holding tank, allowing the polymer dispersion to cool and stabilize. During this holding period, any remaining polymerization reaction can continue until completion, resulting in a more consistent product. In addition, the blowdown vessel serves as a buffer between the batch reactor and the continuous stripping tower. This ensures a stable and continuous flow of material while reducing pressure surge that could damage downstream equipment. Overall, the blowdown vessel plays an important role in ensuring operational safety, protecting plant equipment, and improving product consistency. Next, I will explain the stripping tower. After leaving the blowdown vessel, the polymer dispersion enters the stripping tower. Although polymerization is complete, small amounts of unreacted monomers are still dissolved in the product. These residual monomers must be removed because they can affect product quality, produce unpleasant odors, and increase environmental emissions. Inside the stripping tower, the polymer dispersion flows through a vertical column under vacuum conditions. Steam or inert gas is introduced as a stripping agent to lower the partial pressure of the volatile monomers. This promotes their evaporation and separation from the polymer dispersion through mass transfer. The vaporized monomers are then sent to a receiver where they are condensed and recovered for reuse or disposed of safely. The stripping tower provides several important benefits. It significantly reduces volatile organic compound or VOC emissions, helping the plant comply with environmental regulations. It also improves the purity, stability, and safety of the final polymer dispersion, ensuring that the product meets BASF high quality standards.
For the unit process number 5, we have receiver, receiver is a vacuum that operated auxiliary vessel located downstream of the stripping tower. Overhead condenser that capture and accumulate the condensed water monomer distillate from the stripped volatile organic compound. It is to maintain the necessary operational pressure balance of the stripping tower, of the stripping column, while providing sufficient retention time for the recovery of the liquid mixture before it is pumped to recycling facilities, which is the process automation is maintained through differential pressure level transmitter and discharge control valve, which is continuously regulate the liquid volume to prevent the operational hazard such as liquid carryover or dry running. For the next unit process, we have a conditional vessel, which is this unit process is a post-addition blend reactor designed to transform the raw material latex into a stable commercial grade product via process chemical compounding to prevent the irreversible coagulation of this shear-sensitive colloidal system. The vessel utilizes a gentle, low shear agitation system equipment with specialized pedals or anchor impeller to safety blend critical finishing agent like pH adjuster, biocide thickener, and antifoam. To automated monitoring lobes for pH, temperature, and the material flow rates are tightly integrated to ensure the precise chemical dosing before the fully stabilized dispersion advance to the final filtration process.
Assalamualaikum. My name is Huri Asafia. So today I'm going to present about the equipment used, which is Sueco filter. So actually Filtration process is very essential for ensuring the products meet the required quality specifications before proceeding to the next stage of production. So the Sweco filter is specifically designed to separate and classify materials based on particle size, allowing manufacturers to obtain a more uniform and consistent product. So this equipment is widely used in the chemical process plants because it helps improve product quality while maintaining the efficient production operations. So one of the main functions of the Sweco filter is to remove the unwanted particles and impurities from raw materials or any intermediate products. So in the chemical industry, even a small amount of contamination can affect the quality, performance, and consistency of the final product. So the last equipment used is storage tank. So at BASF, storage tanks are commonly used for storing polymer dispersions such as arclic dispersion, stearin arclic dispersion, carboxylated stearin butadiene dispersions, or is it called as XSB, high solids latex, HSL, and also resin dispersions. So these materials are often delivered in bulk quantities by road tankers or rail tankers. So the storage tanks provide a safe and efficient method for receiving, storing, and handling these materials before they are used in the manufacturing process or distributed to customers. So bulk storage also reduces the need for the excessive packaging and manual handling, making operations more efficient. Okay, so let's see the occupational safety and health that have been provided by the BASF to the employees. So firstly, BASF have a proper method for handling and storing flammable materials. So actually, BASF fulfills strict safety measures, including proper chemical storage procedures, hazard identification systems, and regular inspection of storage facilities and processing equipment. So second is the employees undergo the training programs. This is to reduce the likelihood of incidents that could result in injuries, property damage, or production disruption. So next, BASF also utilize advanced monitoring and control systems. This is to decrease the process temperature and pressure to avoid equipment failure or unsafe operating conditions. Lastly, BASF applies preventive maintenance programs, routine equipment inspection, and strict operational procedures. This is to reduce the risks associated with pressure system and rotating equipment.
Next, I will discuss several technical problems that may occur during polymer dispersion production. The first issue is poor emulsification, temperature spikes, and coagulation. These problems are mainly caused by poor mixing, unstable temperature, and poor pH control. As a result, product quality becomes inconsistent and production yield decrease. The current solution is to carefully evaluate process parameters and optimize operating conditions. As a continuous improvement, BASF can implement high-shear mixers together with automated temperature and pH control systems to improve process stability. Another common issue is premix instability of spec products and inconsistent viscosity. These problems are usually caused by variations in raw material quality and inadequate process control, leading to lower production efficiency and increased product rejection. To address this issue, the company can optimize formulation procedure, improve mixing condition, and strengthen quality control. Further improvement include using statistical process control, predictive analytics, and automated control system to maintain consistent quality. Finally, I will explain the environmental and safety challenges. One environmental issue is chemical spills and waste discharge caused by equipment leakage and improper waste handling. These incidents can lead to environmental pollution and regulatory penalties. The current solution is to improve waste management practice and repair leaking equipment promptly. For continuous improvement, leak detection systems and cleaner production technologies can be introduced to minimize waste generation and environmental impact. In terms of safety, one major concern is reactor accidents and product contamination. These problems may result from inadequate safety systems and poor hygiene practice, potentially causing worker injuries and product recalls. To overcome this issue, BSF should strengthen Standard Operating Procedure or SOP, conduct regular operator training and perform routine safety audits. Additional improvement include installing emergency shutdown systems, implementing CIP systems and using real-time process monitoring to improve plant safety and product quality.
Okay, so we already arrived at the end of our slide and project. So the conclusion for our project is that we successfully enhanced our understanding of the polymer dispersion manufacturing process at BASF. It also demonstrated the practical application of mass and energy balance concept in an industrial setting. Next, it's improved our knowledge of process equipment, process control, and product quality management. It's also increased awareness of occupational safety and health OSH practice in chemical industry. Lastly, it bridged the gap between classroom learning and real industry operations, preparing us for the future engineering careers. So that's all from our group. Thank you.